Corrosion doesn't sleep, it doesn't take holidays. The moment steel touches seawater, the clock starts ticking, unless you give it armor. Protective coatings are the first line of defense, a physical barrier, standing between steel and the forces that want to break it down. But that's not all. Coatings also help reduce the electrical demand of cathodic protection systems. Less exposure means less current needed. Simple math, strong science. I start with the classics, paints and epoxies. These are applied in layers, usually a primer underneath and a top coat above. Thickness, between 25 to 100 microns. Enough to form a protective skin, but not too thick to crack or peel. But here's the catch. Surface preparation is critical. Blast cleaning, to SA3 standard, ensures proper adhesion. Because even the best paint won't stick to dirt and rust. And when it comes to epoxies, they're engineered to resist water absorption. Perfect for humid zones, splash areas, or marine decks. Now imagine a coating that doesn't just block corrosion, it fights it. That's the power of zinc-rich coatings. They're made of zinc dust and silicate binders, and they act like mini sacrificial anodes embedded in the coating. If there's a breach, the zinc gives itself up first. The steel, still protected. It's passive and active, in one smart layer. Next, I get heavy. Gunite or cement-based coatings are used in pipelines and splash zones. They don't just stop corrosion, they take on mechanical impact, wave slaps, and abrasion. Yes, they add weight, but in places where strength matters more than agility, they're the go-to choice. Sometimes paint isn't enough. You want metal-on-metal protection. Enter metallic coatings. This includes hot-dip galvanizing, immersing steel in molten zinc, electroplating, applying metals through electric charge, thermal spray coatings, particles melted and sprayed at high velocity, and diffusion coatings, where protective elements literally merge with the base metal. Common metals used? Zinc, aluminium, and cadmium, each chosen for their corrosion resistance. And then, there's the high-end protection, the armor plating of corrosion defense, cladding and sheathing. Imagine wrapping steel in a coat of Monel, Inconel, or other superalloys, not sprayed or brushed on, but physically bonded using techniques like explosive welding, buttering, or rolling. These aren't just coatings, they're structural upgrades, used in high-risk zones, risers, and mission-critical components. Let me bring it together. Paints and epoxies. Layered protection, easy to apply, needs surface prep. Zinc-rich coatings, barrier and backup, passive and active defense. Gunite or cement, heavy-duty, impact-resistant, built for rough environments. Metallic coatings, galvanized, sprayed, plated, metal protecting metal. Cladding and sheathing, high-performance alloys, physically bonded, premium protection. Each has its place, each has its purpose. Together they build the armor that holds back corrosion, because sometimes it's not just about stopping rust, it's about protecting value, extending life, and building structures that last. So the next time you see paint on steel, know this, it's not decoration, it's defense.